Okay, today I'm going to go through the 6.4 to 6.6 practice work. So that's on a big giant PDF, several old things to help us review a little bit. So that's all we're going to do right now. So the first one has a 1 up here at the top, says quiz 6.4, has a 1 up at the top. And the first question says, we have r equals 4 cosine 7 theta. How many leaves does this have? Remember, this number right here controls the number of leaves. If it is odd, that's how many you have. So this one has 7 leaves. Remember, if that number is even, you have twice that many, but it is odd, so we have exactly that many. That's question number 1. 2 says we have this curve, and we want to know what the name of it is. Now, this is the giveaway right here, r squared. Only one of your classical curves has an r squared. When you have an r squared, you have a lemniscate. And the shape of that, remember, is a figure 8. Lemniscate, figure 8. But we just want to know what shape it is. If it has an r squared, it is a lemniscate. 3 says we have a point, but it has a negative r value. So we want to know, if we were actually going to put this on our graph paper, where would we put that point? You can't plot a negative r. So we have to change that r value to be positive. And when we make r positive, we use the opposite angle. So what we mean by that is, if you were going north, you'd be going south. The opposite. So it's 180 degrees different. So instead of plotting it at 10 degrees, we'll plot it at 190. Remember, when you change the sign on your r, your angle changes by 180 degrees. Number 4 says a spiral that spins outward. So in other words, it starts here and spins outward. What kind of a spiral is that? It is a spiral of Archimedes, or an Archimedean spiral. It starts at the pole and spins out. Number 5 says draw a freehand sketch of a Lima sign. Well, the word Lima sign should remind you of Lima bean. So you can draw this like that. You can actually draw a heart shape if you prefer. That's a form of a Lima sign. Those are 2 examples of Lima signs. Any kind of dented in shape like that is going to be a Lima sign. And then the last question says find rectangular coordinates for 4,60. So these are polar coordinates, and we're going to change these into rectangular coordinates, which means we have to find x and y. We have to find x and y. Now, if you've been keeping up with your videos, watching all the videos, you know that x equals r cosine theta and y equals r sine theta. So x equals r cosine 60 and y equals r sine 60. I know the paper says no calculator, but you can go ahead and do this on your calculator, given the circumstances. So go ahead and just type in 4 cosine 60, and we get 2. And for sine 60, we get 3.46. Perfect. All right, now the next page of your PDF is already done. I put that one in twice accidentally. I don't know why. 6.4 practice quiz is already done, so I'm not going to do that one. I'm moving on to the next page, which says Precal C quiz 6.4 to 6.6. And the first question is -3, 5. We're converting to polar coordinates. So we've been given x and y, and we're going to convert to polar. Now, polar means r and theta. So to find r and theta, I'm going to draw a picture of my original point, which is left 3 and up 5. Left 3, up 5, xy. This is r, and this is theta. Now, to find r, it's really, really simple. To find r, we square the first one, square the second one, add them up, and take the square root. So r is root 34. It's the Pythagorean Theorem. If you ever have a doubt, just do the Pythagorean Theorem, and that will find r. Now, to find theta, that's going to be a little bit tougher. To find theta, this angle right here, I'll call it A. I can find it because I know that the tangent of that angle equals 5/3. So all I have to do is type in on my calculator, second tangent 5/3, because the tangent of the angle is 5/3, so the angle is second tangent. So second tangent 5/3, I get 59.04. So this angle right here is 59.04. That is not my theta, though. No, no, no. This is not my theta. This is my theta. So how will I find my theta? Well, if I went all the way to here, it'd be 180. But I stopped before I got there. So I'm going to have 180 minus 59.04, and it's 120.96. So 120.96 is your actual theta. Okay. Now we have, we're going to do the opposite now, which we just did a couple seconds ago, so this is going to be easy. We have 7, 135, and we're changing that into rectangular coordinates. So this is r and theta, and we're going to find x and y. Okay, so x equals r cosine theta, and y equals r sine theta. So just go to our calculator. 7 cosine 135 and 7 sine 135. So I got negative 4.95 and positive 4.95. And those are my rectangular coordinates for this point. Easy enough. Okay, number 3 says write as a polar equation, and it's x plus 4y equals 2. Now, guys, they don't get any easier than this. Remember, I've had you highlight this in your notes over and over and over again. So x equals r cosine, so I'm just going to make r cosine theta plus 4 times r sine theta. And that's the answer to the question. That is all that you have to do. Substitute in r cosine theta for x. Substitute in r sine theta for y. Now you have an equation whose only variables are r and theta. Believe it or not, 4 is very similar. We have the number 5 CIS 97, and we're going to change it to rectangular form, which means x plus yi. Remember, it's important to take good notes. That's rectangular form right there. That's what you want your answer is going to look like that. Which basically means you have to figure out what x and y are. Well, wait a minute. How do we figure out what x and y are? Right here. This is your r. This is your theta. So x is 5 cosine 97 and y is 5 sine 97. So we'll just type that in on our calculator. 5 cosine 97 negative 0.61 and 5 sine 97 4.96. Remember, the I goes with the Y, so the I goes with the sine number. And that's it. Easy peasy, so important right here, guys. So very important. Okay. Oh, the next one we've already talked about. You have this point. This may be actually the same problem. Where do I plot that? Well, the r has to be positive. You can't plot it with a negative r. That won't work. So you have to make the r positive. And when you make the r positive, your angle changes by 180 degrees. It goes in the opposite direction. I don't know how else to describe it. If the original angle was this way, the new angle would be this way. And that's 180 degrees. You change it by 180 degrees. 6 says draw a freehand lemniscate. Well, again, if you pronounce the word wrong, if you say lemniscate, then you can see it graphs as a figure 8. So it can be sideways, it can be diagonally, it can be up and down. Some kind of figure 8 is a lemniscate. All right, and then finally the last one, this is number 7. We're changing it to polar form. So we are changing it to this. This is polar form. So this is x and this is y. And we have to find r and theta. So you'll remember to do that. We draw a picture of our original number here. So we go over 2 and down 5. And this is r. So remember, we can do the Pythagorean Theorem. Square the first one, square the second one, add them together, and take the square root. So r is root 29. Now, theta is the trickier one. This is actually your theta. The big green angle is your theta. You can't find that right now, though. You're going to have to find angle A first, the one inside the triangle there. And we know that the tangent of angle A is 5 halves. Tangent is opposite over adjacent. So the tangent of angle A is 5 halves, so we can what in the world? So we can second tangent 5/2. So if I second tangent 5/2, I get 68.2. Now I need to figure out my theta. Theta is this whole big angle. So it goes all the way around. It goes to here, that's 180, and then it goes 68 more. So that would be 68.2 plus 180, 248.2. That is your angle. Oh, don't fear, there's more. So now the last page actually has 2 on it. So that's good. It's just a really basic review. So it says, first one says, name the 4 classical curves. Well, you have the rose, the Lima sign, the lemniscate, and the spiral. There are your 4 classical curves. R squared equals 4 sine 2 theta. I know some of this is redundant, guys, because these are different quizzes that I've had over the years, but it's all good practice. It says, which curve is this? This, of course, is the lemniscate. The dead giveaway is the R squared. When you have an R squared, you're going to have a lemniscate. Remember, the Lima sign has the add or the subtract in it. This has the R squared, and this has no sine or cosine at all in it. So if it has a sine or cosine, does not have an R squared, does not have plus or minus, then it's a rose by the process of elimination. All right, a spiral that starts out and spins in. So in other words, it looks like this. It's starting out and spinning in. That is hyperbolic. That is a hyperbolic spiral. It starts out and spins in. So here's a rose. This is a rose. 4 sine 4 theta. Notice it does not have an R squared. It does not have an add or subtract. And it does have a sine or a cosine. This is a rose. How many leaves does it have? Remember, that number right there controls the number of leaves. If that number is even, there are twice that many. So this problem has 8 leaves. If that number is odd, that's how many there are. But this is even, so there are 8 of them. Remember, this number here controls the length of the leaves. This controls the number of the leaves. 5 has you looking at the equation 3 minus 4 cosine. Is that a cardioid? No, it is not a cardioid because 3 and 4 are not the same number. If you are going to be a cardioid, then these 2 numbers are going to have to match. And they don't. So that's just a generic old Lima sign, not a special Lima sign called a cardioid. Okay, and then number 6, we actually have to do some math on number 6. Number 6 says change to rectangular coordinates. So we have 360, and we're going to change that to rectangular coordinates, which is x comma y. Well, we've done this already a couple times. Remember, x equals r cosine theta, and y equals r sine theta every time. So this is r, this is theta. So x equals 3 cosine theta, and y equals 3 sine theta. You just type that in on your calculator. 3 cosine 60 and 3 sine 60. So I got my ordered pair to be 1.5 for my x and 2.60 for my y. To find x and y, to find rectangular, bingo, right here. Okay, there's one more paper to do. The one that says period 3 needs to focus. So the first one says convert to polar. So that means you have x and y and you want to find r and theta. Remember, polar means r and theta. So I'll draw a picture of this. Over 3, down 1. Obviously my scale's off a little bit, but you get the idea. Over 3, down 1. This is r. And this is theta. So r's Pythagorean theorem. Square the first one, square the second one, add them up, take the square root, so root 10. Now I need to find this angle right here. To find that angle, I'll say the tangent equals 1/3. Opposite over adjacent. So the angle is going to be second tangent 1/3. Now, second tangent 1/3 is 18.43. So this angle is 18.43. That is not theta. Please don't put it up here. It's not theta. How are we going to get theta, the green angle? How are we going to find it? Well, this is 18. All the way around is 360. So what if we do 360 minus our 18 angle? 341.57. And that is your theta. 360 minus that much. The next one is the opposite. We've already done a couple of these. Again, I know it's redundant, but it's just more practice. We've already done one like this, 4 200. These are the polars, and you want to convert it to rectangular. So that means you're looking for x and y. I'm not even going to write it down again. I've written it so many times. X equals r cosine theta, and y equals r sine theta. So 4 cosine 200, 4 sine 200. So your coordinates are 4 cosine 200, 4 sine 200. I got negative 3.76. And negative 1.37 as my x and my y. Number 3 is another really super simple problem. This is a rectangular equation. This is what's in the problem. But it says change it to a polar equation. So that means we don't want to have x's and y's. We want to have r's and thetas. So what does x equal? R cosine theta. So I'm just going to replace x with r cosine theta. I'll replace y with r sine theta. And we're done. There it is. That is your handy dandy little polar equation. Now the next one's a little bit tougher. This is a polar equation already, and we're going to replace it with, or convert it into a rectangular equation. So I haven't done one of these in a while, so think back, look at your notes. First thing you want to do is substitute in the definition for sine theta. So this goes all the way back to your gold sheet. How long ago? 4 times, okay, sine is y over r. If you have forgotten your gold sheet definitions and you can't find your gold sheet, then you need to look them up in your textbook. You need to know the definitions of the functions, because the first step in this problem is going to be to change the function into its fraction form. So if it were cosine, it would be x over r. If it were tangent, it would be y over x. You have to know those definitions. Now, whatever the function is, this will be a fraction. When you substitute in, the definition will be a fraction. So the next thing you're going to do is clear the fraction. So that's going to give us this, because those are going to cancel now. We're going to have this. And then here's another thing you have to remember. Every time we have an x and a y and an r, every time, the Pythagorean theorem works. So x squared plus y squared equals r squared. So when you see this r squared here, you're going to replace it with x squared plus y squared. I hope you're taking good notes. We talked about that before. This is a little bit tougher problem. First of all, replace the function, the trig function, with its definition. Clear the fraction. And then in this case, you have an r squared, which you have to remember is the same as x squared plus y squared because of the Pythagorean theorem. And this is your answer. That is your rectangular equation for problem number 4. Number 5 says we have the point -3, 2, 10. And we have to figure out where we're going to plot it. Well, we know we're going to plot it with a +3 because we cannot plot it with a -3. So we know we're going to plot it with a +3. Now, what does that do to the angle? We've already done this a couple times in this video. What happens to the angle when you change the sign on R? It changes by 180 degrees. Now, if you think about a circle, if you started here, and if you went 180 degrees in this direction, or if you went 180 degrees in this direction, wouldn't you end up in the same point? Yeah. So it doesn't matter if we add 180 or subtract 180. We're going to end up in the right spot. So I'm going to subtract 180 and get 30 degrees. If I add 180, I get something bigger than 360, and then I'm going to have to deal with that. So I would rather, in this case, subtract 180. If you want to go halfway around the circle, if you want to go the opposite direction, it doesn't matter if you add 180 or subtract 180. So given this angle is so big, I'm going to subtract 180 to get 30. Now, if you're saying, well, Miss Ford, what if I added 180? Well, you could add 180, but then your angle is going to be too big. If you add 180 to that, you're going to get 390. you can't use an angle bigger than 360. So you're going to have to shrink that down by subtracting 360, and you're going to end up with 30 anyway. So it doesn't matter. It's just easier to subtract 180 to start with. And then number 6, we've already done this on a different quiz. I'll write them out one more time. Name the classical curves. The classical curves, remember, in any order, are the rose, the spiral, the Lima sign, and the lemniscate. These are the 4 classical curves. There are many, many, many other shapes. Many, many, many other shapes. But these are the 4 what are called classical curves, and you can list them in any order. Okay, good job.